Okay, sorry about that tonight. We were in very short on time. That first part took a whole lot longer than I thought it was going to take. And it was kind of compressed even with my original plan. So somewhere between dismissing class a few minutes ago and coming home, making a pot of coffee, I decided, well, instead of just adding comments to that very quickly thrown together thing, why don't I do the whole lecture like I had originally planned, or would have liked to done if there had been enough time? And kind of going slow here at the first, because down here at the bottom, when I edit the video, I'm going to put some times for jump ahead parts if you just want to skip ahead to some stuff. I'm going to go ahead and do the whole lecture like I would have liked to done if I had time. So we're going to, the book kind of overcomplicates this, I thought. So we're going to use async thread. We're going to use an asynchronous thread to grab an RSS feed. That's kind of the goal. I probably shouldn't have tried to put that in an hour. But what the book does, I thought was way overcomplicated, and then they used that to introduce some other examples. So, for one, as opposed to the textbook grabbing a big fancy RSS feed from CNN, we just made that simple RSS feed out of and stuck that on the Bobby server. Everybody in class has a Bobby server, so somewhere off in the cloud, the internet. We have this RSS feed. Which you might remember stands for Really Simple Syndication. So let's pause for a second and look at the one we put together the other day, getting prepared for this lecture. The RSS feed, as you remember, we put together in class, a nice simple one to work through an example with. So we can go over to the internet and find that. Everybody in class has used the Bobby server or has a Bobby server account from a previous class, the HTML class or the JavaScript class, one of them. It's going to be bobby.ivtech.edu/tilde username. Mine's cfrancis4 if you want to use my RSS feed. It's on here under RSS-fall-2019. And RSS, really simple syndication. Why put RSS there? Oh yeah. Really simple syndication. We have it's just an XML file. So we have channel tags, which these were kind of set up so that a standard RSS feeder would recognize our stuff. We can call the tags whatever we want because we'll be parsing through the data ourselves. In particular for us, when we grab the feed, we want these items. This stuff up here is just information about the feed. So for example, on the CNN site that the book uses, their feed items are going to be news stories and come out a lot and change a lot and update and have a lot more going on. That's why I wanted to do this simple example. So this is the information we're going to grab, these item tags, and we're going to grab a title, a description, and a date out of it. And again, it's just an XML file. We can call these whatever we want. We're going to look for them ourselves. We'll see that when we get to the code here in a few minutes. So that's our RSS feed that we're going to work with. We'll come back and edit a little, add some stuff, make some modifications, see what happens in our code. What we need our program to do is go out to the internet, grab that RSS feed, bring it back. I'll color code this. So then we'll make an array of Java objects to hold that information. I'll kind of compress a little bit in the drawing here, because all we had is 3 strings: a title, a description, and a date. Then we'll make an adapter to inflate that information, that array into a list view. That thing we saw earlier that burned up all the time in class. So we're going to go to the internet, grab the information from the feed, put that in an array of objects to organize it, throw those on the layout, create an adapter to put that layout into a list view, and it'll run over and over again. So a couple things we'll need to do in order to do this. For one, when we go check the internet, there could be a delay, so we don't want to wait on that. So that's where the asynchronous threading comes in. We want that to run, this part to run on some thread off in the background. That way the user, well, in our example, our app's not going to do anything else. But in a bigger app, the user doesn't have to wait on the information to come back from the internet if it's not immediately necessary. They can keep doing other stuff, and then that information will get back when it gets back. So we need to thread off in the background. So that's our asynchronous threading. It's going to come back in, and it can go ahead and handle all of this. Since we need to be on an asynchronous thread, we'll do it all in the background, and it'll just show up on the screen when it's ready. So I guess we can jump over to Android Studio and work through this example and run it and make sure it works, and hopefully this will all make sense. Slightly slower and more detailed than we did in the last, half-hour class there, trying to show all this information in class, and actually all the way through an example. So let's go get started on that. Okay, so here at Android Studio, I'm just going to scrap that version, that quick version we did in class, and start a new project and go all the way through it. So these things we've seen a few times. We're going to start a new project, an empty activity, click next. So it looks like the directory's in a good place, and I'm going to call this RSS feed reader example. And for class, this will be okay. When you're making apps to sell on the Google Play Store, you might want to do something a little later than 16. Something a little newer than that. But that'll work for class, and at that point you'll probably have your own package name that you use. And we'll let Gradle run all this, and there's no need to video of the Gradle build running, so I'm going to pause this and restart in just a second. Now that the Gradle build is finished, we can jump in here, get this out of the way. And since we're not rushed for time, as mentioned in class, I don't want to spend a whole lot of time here. I'm going to do the way we normally would and make the layout files first. So I guess the first thing is create the layout that we need to work with. So I'm going to right click on layout and get a new layout resource file. I'm going to call this feed item layout with underscores, and I want to change the root element. I like working with constraint layouts, so type con, that brought up Android x.constraintlayout.widget.constraint layout. Yeah, that's what we want our root element to be. Definitely put it in the main folder, and it goes in the layout folder. We don't need any modifiers. We're just going to do the default one to start with, and then the modifiers usually go in copies of the default anyway. Hit OK and let that generate. So, as we saw in the RSS feed, basically we just have 3 strings. So I'm going to go ahead and bring those in and set them up and constrain them somewhere. Like always, 2 constraints is kind of enough to do this. txt title. We need an ID to refer to it. And probably want to make the title kind of big. So the placeholder text is going to be replaced. So we'll just leave that there. Way down here in all attributes, eventually we'll get down to text size. There's not a dimensions folder yet to type into. So I was, as mentioned in class before, I like to go ahead and have the dialog box create the first one, and then I'll usually just type in the folder after that. So this will be title text size. What's a good size? I don't know, 32 dips or sips or whichever one you want to use. Nice big title on the screen. And these are going to be small boxes, so we don't need it spread out too far. So I probably should change this because I'll be previewing this on a 1280 by 800 tablet. So we've talked about it in class. This isn't exactly accurate. Android Studio will drop memory resources from these graphics first because it's actually this text file over here, XML file, and the graphics are just to help us. But it gives us some sort of idea when we're laying stuff out. It's very helpful. So that'll be our title text. Now that that created the dimension file, we can go in here and set up dimensions for our other 2. So we'll also need a dimension tag for description. I spelled that wrong. SCRIPTION. Description text size. And I'll make that, I don't know, 22 dips. And then our RSS feed also had a date, so I'll put the date kind of small at the bottom. Date text size. 12 dips. That seems to fit that pattern nicely. So that'll give us the dimensions for the text size here. And I can drag in those other 2. So I'm just going to constrain the description to the title. That way the left side's aligned. And somewhere here, there it is, I think. Click that. Yes. Give it a little bit of padding. And keep the left side, and that'll work. So this one will be txt description. And for text size, we have that set up. So we scroll down here, somewhere under all attributes, way down at the bottom. We have that set up. So at dimension, description text size. Whoops. At dimension / description text size. Where's my keys not working? There we go. And then a text view for the date to go into. I'll just attach that to the bottom of the other text view there. That's too close to grab the thing. And I'll put the date over here. That'll work. This will be txt date. Give it an ID so we can refer to it. Then way down here under text size, that's going to be add dimension / date text size. So that'll be our layout. That'll give us enough for the layout that we can inflate into a list view. Might as well stick with layouts here. I think everything has a name or an ID. That'll work. We're going to close this. And in our main activity, I'll get rid of this. And we could set this up to happen automatically. I think I'll do it on a button click. So I'm going to use a linear layout this time. Vertical linear layout. And I like to go ahead and click the constraints. That's probably not necessary because we also want to make sure that our layout width is set to match parent. Same thing for height. I believe I mentioned it in the first example. Sometimes the list views like to go with the numbers, and the Android device will think the whole thing's showing and it won't show the scroll bar. So you want to make sure that's set to match parent so that it goes into the size of the screen. So then in here we can put a button up at the top. Why is it saying no component selected? Okay, that's going awful slow. While that's doing it, we need some words for the buttons. So I'll come over here and make a string resource. Button get RSS feed. Get RSS feed. And did this catch up now? There it goes. Button get RSS feed. And our text for the button will be at string button get RSS feed. And then below that, we can bring in list view, which is under legacy. And it's set to match parent here. So that'll be good. So it'll just fill out all this that it can. And we just need an ID to refer to it. So LST feed. That'll work. And that's basically all we need for the layouts. Pretty much everything else will be in Java code. So I'll go ahead and close this. And it looks like I'm coming on 11 minutes of video. So I'll stop, render this down, and start a new one. And be back in just a moment. So more board stuff real quick. So we're going to use asynchronous threading to go grab the RSS feed and kind of introduce that. So with that, we'll need to talk about generics real quick. So there's this object that we're going to extend that has all the methods we'll need built in. That is called async task. And it's going to take in generic types, which we define with the angle brackets. 3 of them in this case. So the angle brackets are used with generic types to write code with placeholders, basically. So when they wrote this code, well, our extension of this, we're going to pass in a string and get back a an array of the feed items that we set up, just a Java object to organize our data. So when they wrote this code, they have no way of knowing that we're going to need to pass in a string and get back an array of feed items. If they would have been able to predict that, they probably would have won the Powerball or something, not be developing software, if they were that good at predicting stuff. So they had no way of knowing it. So when they set the object up, they had to use generic types. And in this case, there are 3 that are needed. So the first one is the parameters that we're sending in. I'll call that S. We're sending in some sort of parameter. I'll put in there. In our case, it's going to be a string. The second parameter is for progress reports. What always springs to mind when I'm thinking of this is like integers or doubles that we could feed back into one of the little meters showing how far along it's come. Some sort of information coming back. We could return a string that gives estimated time left or things like that. But some sort of intermediate return value. It's not the final return. It's not what we're waiting on, but some sort of value, most often to tell us how much longer we're going to be waiting for it. And then the final generic type is the actual return type, what's coming back. And when they built the object, they set it up with generics, which are basically placeholders. They needed something to write the methods with. So they put in these generic objects, which we define with angle brackets. We've seen them before with array list and any type of list where we have to say what type of object we have. It's not entirely coincidence that we use the angle brackets in the RSS feed as well, such as one of our things has a title tag. It is kind of related because we take this text that we wrote here and turn it into a title type of thing. So when we parse through it, we're going to look for the text that is of the title type. They're not completely unrelated. Why we use the angle brackets in both cases. But for us, the generic types, we need to define objects to fill in those generic placeholders that they left when they wrote the code. Something to send in, which in our case, we're going to send in a string, in particular the URL to our RSS feed. And these have to be objects. So if you need integers, use integer with a capital I instead of ints. Booleans with a capital B. No primitive types. Has to be the object version here in Java. Which is important for us on this next one because the progress, we're not going to receive any progress reports. We don't need any in this example. So we don't need to return anything, so that's a void. That's what we put in our methods. But we need the object version. So with a capital B, yes, there is an object version of void. The object version of absolutely nothing. I think it was less than null, because null is still an object. Null is the object of nothing. A void is less than that. But we have to have something there, so that does exist for the computer. And then we're going to return, well, we'll be over to Android Studio in just a moment. That's going to be the first thing we write is a Java class to organize our data. And that way we can work with an array of those objects rather than a bunch of separate arrays full of strings and try to line them back up. we'll just go ahead and organize them all into an array, call it feed items. So that's the three types of objects we're going to pass in. It's not the actual return. The generic, we just have to say what type of object we're going to use. And then in the methods, we'll use those objects. In particular, async task is abstract. The method that we're required to implement is called do in background. Kind of obvious what it's doing. So it's going to take in the string, do a bunch of stuff in the background, and when it's done, it's going to return feed items. And we don't necessarily need to return them all the way back to our main thread, because these two threads, even though this asynchronous thread that we created is going to run off in the background somewhere, it's still somewhat connected to our main thread. It's not synchronous, so it's not running with our main thread, but it's not a completely separate program. So we can do some of the things from this. In particular, we're going to get these feed items, and then in this class, there's also a method we can override called onPost execute. There's also pre-execute, which is obviously before we do stuff in the background, and post-execute, which is after we do stuff in the background. And then some other ones, we'll look at that list quickly when we get back to Android Studio. And the feed items that our background stuff returns will pass into the onPost execute, and we'll use that method to inflate our layouts with the data in the feed item array. So let's go over to Android Studio and get started on that. I just wanted to talk quickly about the generics. By the time you got in this class, hopefully you've seen those before at some point. And it's just, when they wrote the code, they had to put in placeholders. They had no idea that we were going to send in strings and get back feed items. But there's no possible way they could maybe guess that string is a good parameter feed often fed in. But we're getting ready to create feed items. There's no way they'd have known we needed back an array of feed items. So they just had to, but they needed some object to write the code with. So the generics are a placeholder. So we have to fill in that placeholder first and say what type of objects we're working with. So let's go back over to Android Studio and work on that. Okay, so back over to Android Studio here. I suppose a good starting point will be our object to organize the data coming back from the feed. So we want that in the same package, that way we don't have to import anything. So I'm going to right click on the package name here in the Project Explorer, a new Java class. I'll call it feed item. And this is just an organization thing, so we don't need things to inherit from anything or any interfaces. A public class. And as we saw in our feed item, we just have 3 fields. And bringing them in here, following good form, we want to make our data fields private to encapsulate the data. So private string title, a private string description, and a private string date. And all we really need here are some constructors and getters and setters. So alt insert brings up this. We can generate, first off, I'll do the empty constructor, so select none. You can also right click and generate, get to the same menu, constructor, and I'll select all 3 of them, holding down the control key for multiple selections, the standard for Windows, and hit OK. So that gives us a couple constructors. Back to this little menu, and we can generate all our getters and setters. Again, just selecting all of them. And that's all this object needs to do. Just basically hold this data and be able to get and set the values. While we're creating Java objects, we might as well go ahead and do the one that's going to do most of the work for us for parsing the feed. And that's a handler object for the feed. So again, in the same package, that way we don't have to import anything, I'm going to create a new Java class. And I'll call it feed handler. And this needs to inherit from default handler. A whole lot of things called defaults, so I have to go a little while until it sense predicts the right one. But here's the one we want: org.xml.sax.helpers. So or inherit from that. Again, it's going to be public. We don't need any modifiers. Don't need any interfaces here. And you can see there's no underlining. Nothing's required of us to implement. There's a bunch of methods we can use. So the plan for this is, as we walk through the XML file from the RSS feed, we can set a bunch of flags, a bunch of Boolean values to determine what we're looking at any particular time. And that way we know where, if we're looking at one of the things we want, we can grab the text from it and put it in our feed item object where we need it. So some values here, we'll need a bunch of flags to set. And if you haven't seen it before, in Java we can declare a bunch of things and initialize them in one long line. Like all the booleans we can do in one line. So we had an item, so let's set a flag called isItem. Title, description, and date. So boolean is for all of those, so we can tell what we're looking at. Is title, is description, and is date. That way we'll know if we're looking at one of the tags or elements we're interested in. Oh, to follow good form, probably want to make that private. That way those aren't accessible from outside our object. We'll also need a feed item. Also need to spell the word private correctly there. Private feed item. I'll just call it current item. This is a new feed item. And then whenever we're looking at, say, the title tag, we'll grab the characters that are in that element, use the setter that we put in this object to set the title value for this object, and then when we reach the closing title tag, or the end of the when we go through all of them, reach the end of the item, then we'll put this object into an array list. Holding feed items. So we need to import that. Use new array list and import those. And you might remember when I was writing this on the board a moment ago, I said we're going to return an array of feed items, not an array list. So we need a method that we'll call to return that. And I like to use array list because they're dynamic and we don't know how many items are going to be in a particular feed. Actually, I was hoping to change it unless the video goes a little long. But we don't know how many are there, so we have to have something dynamic. But a regular array is a little more efficient because we don't have extra spaces for items coming along, and we don't have all the overhead for making it dynamic coming along. So we need a method obviously public to return those. So public feed item, something that's going to return an array of feed items. I'll just call it get feed items. And what this is going to do, it will create an array of feed items. I'll just call it temp equals new array of feed items. That is going to be list.size. The size of that list, because we'll know how many items we have by that point. Then we can do list.toArray and feed the array into that, feed the list into that array and return that. That way we'll be working with an array of fixed size once we know how many there are in there. So might as well set up a constructor while we're here. Public feed handler. I'll just set up a default constructor. It doesn't do anything. Might come back and do something. If there's errors, that's a good place to put echoes for checking things. Now we can just work with some of the things built into default handler to parse our code. So Alt insert or right click and generate, and we can go to override methods. So here's the methods built in already or set up for us to use. Start and end of document, those we often want to do things with that. Echo back a message that says we found the document when we get to the start. For us, we're going to use the start of an element, the end of an element, and the characters. Those three arrays, or those three methods. Let's see, I'm going to change the order here and put it in the order we're going to do stuff in. So obviously start element is when we hit an opening tag. End element is when we hit a closing tag. And I should probably have the thing open to refer to. Let me open that. So if we look at the feed here, obviously when we hit an opening tag for an element, that first method is going to run. Our start element is going to run. So that's where we'll set all our flags so we know what element we're inside of. And when we hit a closing tag, that's going to, any of these closing tags is going to trigger this end element to run. So there we'll know we're at the end. And in between an opening and closing tag, there should be some characters written. So we'll fill those in there. So at our RSS feed, we want to come down here, and when we get to an item tag, we'll set our flag. Then we want to check and see if we're in a title, a description, or a date tag. So go ahead and set our flags here in this method. So it passes in a couple things we can work with. The uniform resource identifier, that's more for a computer to use. Local name and fully qualified name, those are what we want. Attributes should be obvious what that does. We didn't include any in ours. Well, I guess here there's a version attribute. If we had any attributes, we could grab them from there. Our local name, that's the tag we're looking at. So here, the local name is item. Here, the local name is description. Up here, the local name is channel. The fully qualified name, that has the whole path to it. For example, for this tag, while the local name is title, the fully qualified name, it's a child of an item tag, which itself is a child of a channel tag, which is a child of an RSS tag. So the fully qualified name would be RSS channel item title if we need the whole to go the whole path through. For us, the local names will probably work. So we can just check that with an if statement. So if local name dot equals item, then we want to set is item equal to true. Whoops. And then we'll just check all of them the same. If it's not an item tag we're looking at, else if local name dot equals title is title equals true. It's not a title tag. Are we looking at a description tag? Is description equals true. And the last one that we really care about when we parse through this is, are we looking at a date tag? So that's where we'll set all our flags when we hit the start element. So obviously when we get to the end element, we want to turn all those flags back to false. So really we could copy this. We'll set this to false. And if we're at the closing item tag, such as this one, that means we just grab a title, a description, and a date. So we'll want to put that. That means our item is going to be filled up, and we'll want to add that to the list. So list.add current item, and then we can kind of reset it. Current item our current item equals a new feed item. We could just use their and setters and change everything. I just like to clear those out. And for the rest of these, if we hit, say, a closing title tag, we're still inside of the item, but that means we're finished with the title text. Same thing with description and date. So on those, we just need to set those to false. When we hit the end of item, we add it to our list, reset it for the next pass through. We'll do the characters here in just a second. And then whenever it's all the way done, then we're going to put that list into an array of fixed size and return that to work within our main code. And it looks like I'm coming on time for this video, so I will pause and render this down and then come right back and finish out this characters method. Now this characters method here. Once again, I'm going to take out the super call. We don't need any of that just to parse through it. So you can see we're being passed in an array of characters along with two integers, a start point and an end point. So that will be the characters between. So like when our flags say that we're in a title tag, all this text here will be passed in as an array of characters along with a start and an end value. So we can just check our flags. So if is item, so if we're in an item, so we can nest all the other stuff inside the item. All the other flags get nested, all the other tags are nested inside an item, so we can nest our flags the same way. If we're in this item tag, we can check if on all of these. So if we're in an item tag, so is item is true, well, we want to know if is title. And if it is, then we have that current item, and we can set title to that array of characters passed in, but we want it as a string. So a new string, and one of the overloaded methods on string is we can pass in an array of characters along with a start point and an end point on that array. And that's what we'll do for all of these. So else if is description. If we're in an item looking at a description tag, we'll grab those characters that are in there and call the set description method on that feed item that we created. We'll pass in a new string with the array of characters, the start position, and the end position. And once again, same thing for date. Is date, whoops, is date, then our current item dot set date to a new string with the character array, start position, and the end position. So we'll set our flags when we hit an opening tag and check those flags to see if it's one of the elements we want to look at. If it is, we'll pass the string that's wrote there into one of our setters for that Java object we created. And then when we hit an ending tag, well, for most of them, we just set it to false. So if we hit a closing title tag, we'll just set that to false and keep going. A description tag should be after that. And when we hit a closing title tag, that means we filled up our item with the title, description, and date. So we want to add that to our list and then reset that for the next pass. So that's all we need for the handler object. So now let's go over to the main activity and set up our asynchronous thread. So there's a couple things we'll need here. Well, we put a list view in our layout. So let's go ahead and set that up. LST, I cannot remember what I called it. Let's go over here and check what I called it. LST feed. That was a good name. Probably should have remembered that. LST feed. We'll instantiate that in a moment. Import that. And as you've heard me say before, my general rule of thumb is if it shows on the screen, that means the user can get to it at any time. So we probably want to be able to get to it at any time in our code. So my rule of thumb is if it shows on the user interface, it needs global scope. And I'll go ahead and put this up here. We also need a string for where to find that feed. So I'll call it feed URL. It's a string, and I'm just going to copy that from the browser. You can just set up, I think everybody was there the night we set those up in class, but if you need to, you can use mine. So the Bobby server, cfrancis4, then rss-fall-2019/fall_2019_rss_feed.xml. That was kind of a long name, but I think we all got one set up that night. So that's where to find our feed. Now, the asynchronous thread, it's fairly typical that since our main activity here should be the only thing to need this particular asynchronous thread. So it's fairly typical to make those as nested classes, nested inner classes. So public class, I'll call it get RSS feed, And as was shown on the board a moment ago, that's going to be a subclass of async task, which takes in 3 parameters. We can see here on the IntelliSense some parameters. We're sending in some parameters. Might get back progress reports and the result to return in the end. So async task, and in our case we're going to send in a string, in particular this string for the URL of where to find it. We're not getting any progress reports, so we need void on the progress, and it's generic type, so we need the object version of void with a capital V, and then we're going to return an array of feed items. And we can see it's underlined, this message we've seen a few times. It's not implementing the methods, it either needs to be abstract or implement do in background. So we can do that right here. Alt insert and implement methods, which is the required overrides. And there's only one that has to be there, do in background. So we can see here it's going to take in an array of strings. We're only passing in one string, so that's going to be at index 0 of that array. And do a bunch of stuff. And then it's going to return a feed item. And we don't necessarily need to return our feed item all the way back up to our main grid. We can do that here because we go Alt insert again and override methods this time. Here's our built-in methods. So a constructor, then pre-execute, so do stuff before we run in the background. Post-execute, do stuff after we're done. So that's the one we want. Then progress, canceled, special cases. For us, we want on post-execute. We can see when we generate the code, it's a void method, but it takes in an array of feed items. So our do in background is going to take in this string to go find our RSS feed. We'll parse through it. We'll write that code in a moment. And then it's going to return an array of feed items, and it's going to automatically pass that array of feed items into this on post execute. So this is where we will inflate the list view. We'll write that in a moment. So first off, what we want to do in the background. Well, right off the bat, we're leaving our program, going to the internet, doing some other stuff, and then coming back. So when we leave our program and do other stuff, it has to be in a try-catch block. Because maybe the user has the Wi-Fi turned off or something like that. There are some specific exceptions we could catch, but for the example, I'm just going to do the overriding catch everything. And why don't I do the catch everything first? What I like to do on these is just to make it easier to find. For debugging, you obviously wouldn't want to leave this in the final version. Is it's expecting to return an array of feed items, and then it's going to throw that on the user interface. So I'm going to make an array of feed items. New feed item. Well, I'll go ahead and write it all out and then return that. So feed item temp equals new feed item. We only need one thing in there because this is just to return error messages. So before I return it, I'm going to go temp.set description. That'll work. Set description. Is that not what I called it? Temp dot where's all my feed item? should be a set description, right? Yeah. There's a new feed item array, temp.set description. Don't know why that's not coming up. And e.print stack trace. Oh. What's this predicting? Let me figure out what that's underlined and I'll be right back. So I figured out what I did wrong there. That temp is an array, not an item. So I'm going to come back here and instantiate it to this. Whoops. I don't need that in there anymore. So I'll put in a new feed item. I'll pass in a blank string for the title. Well, I can put error. Something went wrong. And a blank string for the day. That way there's some sort of error message showing on the screen because it'll return this array then and then throw that up on the user interface. That way we don't have to dig through the logcat or the run to see to get the error message or to know if something went wrong or see our app crash. So now the stuff we want to do in the background. So we have the URL as a string. So we need to convert that to a URL object. URL feed URL. Oh, that's already used. I'll just call it URL. It's a new URL with that. We're going to pass that string in. So we have this array, and we'll just need the first index in it and import those. The next line is where we set everything up. So we need an XML reader. I'll call it reader. And that'll equal a one nice thing about videos is I can edit out mistakes. So the XML reader, we're going to get that from a Sax parser factory. And we could do this in multiple lines, but the only reason we would need a reference here is to create the next one. So we can just keep going. .new instance, .new Sax parser, .get XML reader. And that'll create our XML reader. If you wanted to, you could split that up to several lines and put references and just call each method one at a time. But we can just do it all as one long line. Once we have our reader, we need that handler object we created. And I'm coming on the end of this time on this video, so I'm going to render this down and finish this out. Y'all shouldn't notice after it's edited though. With our reader running, now we need to set up a handler for that reader to work with, which is the thing we made earlier, this feed handler.java object. I'll just call it handlers, a new feed handler. And then we can set that. So reader dot set content handler, obviously to that handler we made. And now we're ready to parse through our XML. So reader dot parse, and we want this one here. It's overloaded method. We want the one with the input source. So we'll do a new input source, and our input source is we're going to go to this URL we set up and open a string. So URL dot open string, and that'll stream in the data from the internet into this reader, which is connected to that handler we made. And then at that point, after that's done, we can return that handler we set up a get feed items method, which you may recall is going to return an array of feed items. And hopefully all that'll work. And then it'll pass those feed items into the onPost execute method, where we can inflate it to that list view, which shows on our activity. So we'll need an adapter to adjust that. So we've seen that in class earlier tonight. So in the package we're working in, that way we don't have to import anything, a new Java class. And I'll just call this feed adapter. And it needs to inherit from base adapter. In particular, Android.widget.base adapter. We don't need any interfaces. It's public, no modifiers in this case. We're just going to inherit from that class, which is an abstract class, but we've seen this. So just a refresher, we'll need a layout inflator. I'll call it feed inflator. And we'll also need an array of our feed items, because we set that up to work with those, make it a little easier to work with. So an array of feed items, I'll just call it feed items, take the suggested name. And then we need a constructor. If we go to Alt Insert and generate a constructor, well, it doesn't quite give us the one option for the one we need. So we need the array of feed items, but we also need the context of where it's going. So I'm going to select the one with the feed items. And then I'm also going to pass in a context object, which I'm just going to call C, which we saw earlier. I use, instead of calling that context, I like to use C because we're also going to call a static method from context. So we'll have, if we use context, we'd have an uppercase and a lowercase c in context in the same line of code. And I found that can be a little confusing when debugging. So this dot feed inflator, this line always looks the same. So we're going to cast as a layout inflator the context that we're inflating a list view into, get system service, and the system service we want is context with a capital C, because it's a static method, so we can refer to the class. Static means there's only one copy, so we don't have to instantiate an object. We can refer back to the blueprint for our object. Context.layout inflator service. So that instantiates our feed inflator. And now we can implement our methods. Well, there's 4 that are required, so obviously we want to go ahead and do all 4. Count, this is how many things show up on our list. So we'll just do feed items dot length, the whole list. If it gets to be really long, you might want to break that up and do 25 a page or something. Cut that down and then give them a next page button and adjust it that way. This next method, get item, well, we want to return the item we're looking at, so feed items, and we're passed in an index, so that's an integer for an index, that's the one we want to use. Get item ID, we can just return the index we're passed in, and it'll use that as the identifier for it. Most of our stuff happens down here in this method. We're passed in an integer, so the one we're looking at, a view group. So we need to set up a view to return. So view, I'll just call it list in this case. And that's going to be our inflator. So feed inflator, that'll equal feed inflator dot inflate. And the layout we want to inflate is r.layout dot, the one we created there, so feed item layout. And we're not creating it in code, so we don't need a root element, so we can just pass in null for the root element. We already set up the layout in XML, so we don't need to create it in Java. So we don't need a root element here. Now you might remember, if not, I'll open this back up and look at it real quick. All we have is 3 text views: text title, text description, text date, and as usual for this class, I'm using the Hungarian notation. 3 to 4 letter prefix saying what it is, and then some useful name. So we need to create those and instantiate those. So text view txt title, import that. And it's not obvious what view to look for in, so we need to make sure, we need to tell it what view to look at. List, and then find view by ID, r.id.txt title for the first one. And I'm just going to select that line. So I push Shift Home to select the whole line, Control C to copy, back to the end, paste, paste, and do the other 2. And we've talked about it before. Remember, it's actually turns out more efficient to work down the list than across, especially when the lists get long. 3 things, it probably doesn't make much of a difference at all. Copy that over here. This is why I like to use the same names for everything, because the computer will never get those confused. Remember, they only look the same to us. They do not look the same to the computer. And now we can set those things. So txt title dot set text, and that is going to be set to the list item we're looking at. So feed items index I dot get title. And again, I'll push Shift Home to select the whole line. Control C, move the cursor back to the end, paste, paste. Change that to description. Change this to the date. So then this one is going to be get description, and this one will be get date. And then we have to, well, this method promised to return a view, so we have to fulfill that promise and return our view. What I call it, list. Probably was many better names than list I could have used there, but that'll work. It's just a reference. And that sets up our adapter. We saw that earlier in class in a very simple example. So now back to the main activity. So when we get to the onPostExecute method, we want to instantiate our list view. So list feed. We declared it up here. My rule of thumb is if it shows on the user interface, the user can get to it at any point in time, and we need to get to it at any point in time. So if it's on the interface, give it global scope. So list feed equals find view by ID, r.id dot list feed, list feed. Oh, then we need our adapter. So we have that feed adapter. I'll just call it adapter equals new feed adapter. Oh, we have to pass in some things. Well, we're passed in an array of feed items, and then we also need a context. I'll type it in here. So if we say this, and then pass in the feed items, oops, feed items, kind of gives us an underlining, because that's ambiguous. So it's we can see here in the error message, it's expecting a context, and we're giving it a get RSS feed. We're giving it an asynchronous thread. So main activity.this is what we want to use. We tell it to go to the main activity class, and then the this part, it'll figure out which one it needs for the context. That's kind of the safe fallback that you can use every time. And then the last thing we need here is list set adapter to that adapter we just made, and that'll inflate the list to that. So that's all we need to do there. There's one more thing we need to do before we run it. So just a quick recap. We set up the string where we want to look on the internet. Oh, I guess we better set up that button. We need to do that before we run it. We've seen these a few times. Button, what did I call it? Button get RSS feed. That was a good name. I'm surprised I couldn't remember that. Get RSS feed. Import the button class, and we'll do that in the onCreate. Button get RSS feed equals find view by ID, r.id.button get RSS feed. Button get RSS feed dot set on click listener to a new on click listener. And when with that click listener, we want to create our asynchronous thread. So we're going to create a get RSS feed object. I'll just use the suggested name as a new get RSS feed. Standard way to create an object in Java. And then we want to execute the code, execute the thread, get that thread to run. So get RSS feed dot execute, and we can see here it's expecting us to pass in a string, which we're going to pass in this feed URL that we made. Feed URL. So when we click the button, it's going to create an instance of this object which handles our asynchronous threading. Do a bunch of stuff in the background, return some feed items, inflate that into our list view. One last thing we need to do, and I'm coming on time, so I need to render this video down, and then we'll do the last thing, but that's not really going to show in the edited version. So the last thing we have to do here, hopefully I didn't miss anything, is we told it to go to the internet and look for stuff, but we have to give permission to use the internet. So we do that in the manifest. So over here in the manifest, the permissions, well, those go with everything we're installing on the user's device. So permissions will go before the application tag. We'll insert a tag, a uses permission tag, and the permission we want to give it is internet. And that's all we need to do for that one. Now that we have permission to use the internet, and I think all the codes wrote, we'll run this and check it. And there's no need to watch the Gradle build run. So I will pause this and be right back, hopefully with the app running or with corrections for any errors that worked in there. So that installed without any problems and ran. As has been mentioned in class quite a few times, I'm not a big fan of emulators, so here it is running on the tablet. You can see I haven't clicked the button yet. Make sure the Wi-Fi is turned on and everything, because we're going to go to the internet and find stuff. That was the whole point of the try-catch block. So we should be able to click the button, and it's going to go to the internet, find some stuff, bring back our RSS feed. I know it's kind of hard to read there on the screen, but you can see it matches first item, second item, just what we put on the list. So that is how we set up asynchronous threading to just do stuff in the background. In this case, go to the internet, find an RSS feed, and bring the information from that feed back and display it on the screen. I thought the book kind of overcomplicated this a little, and the next few homework assignments are based on that, so hopefully you can get through the slightly more complicated version the book does, having seen a simpler case. And this is going to be a portion on the final. You'll have to do this on the final. It's kind of important to be able to go to the internet and grab some data and use it. We'll review this on Monday after the holiday. Everybody have a good Thanksgiving, and I'll see you next week.